Oh, huh. Good morning, ladies and gentlemen. It's February 2, 2022. This is David De Los Reyes. I am here in Los Angeles, California. Okay. My next discussion on my channel for this morning, it's still this morning. It's not yet 12 plus. My discussion for this morning is some more examples on the so-called integration by parts. Yesterday, I gave you examples on integration by parts. Now, I will give you more examples, the more complicated ones. Okay, let's proceed. Integration by parts, examples that are more complicated than yesterday. Okay, example number 1. The integral of arctangent of 3x dx. Arctangent of 3x dx, the integral. We are on the topic integration by parts. So this should fall under the integral of, we got the formula for this one. The integral of u dv is equal to ub minus the integral of d du. Okay, this is the formula for taking the integral of this, since the topic is integration by parts. Okay, I will let u equal to arctangent of 3x. This portion here, I will let that as my u. And this dx here, I will let that as dv. Okay, let's compute for the value of u and dv. If u is equal to arctangent of 3x, arctangent of 3x is just the same as arctangent of 3x over 1, right? If there's no 1 over here, it's understood to be 1. Or actually, we could write it as arctangent of 3x over 1. Okay, let's compute for the value of du. The differential of u is equal to the differential of arctangent of 3x. Under arctangent, we did that the last time around. It should be dv all over a square plus b square. Meaning, if you take the differential of both sides, okay, the differential of u is du, the differential of arctangent of 3x over 1 is, we follow the formula. I am just recalling the formula. It should be dv all over a square plus b square, okay? Where the value of a is 1 and the value of b is 3x. Okay? Where did this came from? It's from 3x over 1. Right? So, okay? So, following this, du will be 3dx. Okay? Because dv is 3dx. Because if b is 3x, dv will be 3dx. Okay? So we will compute this, place this value 3dx over here. We are following this. 3dx all over 1 square, 3x quantity square. Or du will be 3dx over 9x square plus 1. That's the value of du from this assumption of value of u. dv is equal to dx. Okay? Then taking the integral of both sides, the integral of dv is just b, the integral of dx is just the integral of dx. Okay? So b will be equal to x. Integral sign, differential sign, they will cancel out each other. So right hand side will just be simply x. So b will be x. Okay? Let's go back to the original problem. The integral of this, we will follow this. So it will be equal to ub minus the integral of b du equal to, it's just a matter of substitution now. Well, what is u? U is arctangent of 3x, right? And what is b? It is x. Minus the integral of b. What is b? It is x. And what is du? What is du? Du is 3dx. It is this. We are just substituting, okay? 3 dx all over 9x squared plus 1. The first part, we are now given the answer. So this should be x arctangent of 3x. Okay, we'll bring out this 3 here. And what remains inside will be x dx over 9x squared plus 1. So to compute for the integral of this, again, we must have to evaluate this one. And I think this is under natural logarithm. If this is to be integrable under natural logarithm, the value of u is the 1 on the denominator. U is 9x squared plus 1, right? du will be 9 times 2x dx plus 0. Or du is 18x dx. Not exact. Why not exact? We don't have the 18 inside. So to bring out the solution, we rewrite this one, okay, minus 3. We will place outside 1 over 18, the reciprocal of 18 here. The integral, okay, of 18x dx over 9x squared plus 1. Okay, this is now under natural logarithm. So the final answer, x arctangent of 3x, 3 over 18 is 1/6, minus 1/6, natural logarithm of 9x squared plus 1. That's the final answer. Okay. It's a very clear solution, right? We assume the value of u in dB. We proceed with the evaluation. After the evaluation, we substitute back it here. If there are some integrations to come out, integrate again. After the integration of this, we will get the final answer. X arctangent of 3x minus 1/6 natural logarithm of 9x squared plus 1 plus c. Okay. Sample number 2. The integral of natural logarithm cosine of x sine of x dx. A little bit complicated, right? There's a natural logarithm here, and the value of the function inside the natural logarithm is trigonometric. This is trigonometric. So it's a little bit complicated, right? In here, I will let you, I will let the value of u to be natural logarithm cosine of x. That's an assumption, okay? And the value sine of x dx, it will be by dv. Okay, let's proceed with evaluation. This is still under the integration first. So if u is natural logarithm of cosine of x, okay, du, take the differential. The differential of u is du. The differential of natural logarithm is 1 over u times du, right? So for this natural logarithm, the value of the term inside is cosine of x. So it should be 1 over cosine of x times the differential of cosine. It's negative sine of x times dx. Or du is equal to minus sine of x dx over cosine of x. This is negative. That's the value of du. dv is sine of x dx. Take the integral of both sides. Okay? The integral of dv, sorry for this one. The integral of dv equal to the integral of the right hand side, the integral of sine of x dx. The integral of the differential of b is just b. The integral of sine of x dx, so it's an exact formula. There's an integration formula for sine. It's negative cosine. So b is actually negative cosine of x. Okay? That's an exact formula from the previous discussion. Therefore, the integral of natural logarithm cosine of x sine of x dx, I'm just following this, equal to, this is ub minus the integral of b du. Okay? Substituting. What is u? Natural logarithm cosine of x. And what is u? Negative cosine of x. Okay? Minus the integral. What is u? Negative cosine of x. And what is du? Du is minus sine of x dx over cosine of x. Minus cosine of x times open bracket minus sine of x dx over cosine of x. Okay? For the first part, this is now a part of our answer, so our only problem is on the second part. And luckily, on the second part, this is minus, ini minus, it will be plus, okay, preceded by minus, so the sign here, before the integral sign is still minus. And luckily, this cosine of x cancel with this. So what will remain inside is the integral of sine of x dx. This is integrable. There is an exact formula for the integral of sine of x. It should be negative cosine. So as a final answer, this should be minus cosine of x natural logarithm of cosine of x. I just multiply this one. Okay, minus the integral of this is minus cosine of x plus c. Simplifying, minus cosine of x natural logarithm of cosine of x. This is minus preceded by minus, it will now be plus cosine of x plus c. Simple if you know your integration formulas. And it's just a matter of recalling and algebraic manipulation. Okay? That's the final answer for example number 2. Okay, I'll try to bring out the last example for this morning. The integral of x cubed dx over the square root of 9 minus x squared. A little bit complicated again. It's a pure algebraic function, but a little bit complicated. I will rewrite the given problem as the integral. I could write it as x squared times x dx over the square root of 9 minus x squared. I could do that, right? Because x squared times x raised to the first power is actually x cubed. I just changed the arrangement. Then I will assume that x squared will be u, and dv is equal to x dx over the square root of 9 minus x squared. So if u is equal to x squared, du will be 2x dx, right? We take the differential. And dv is x dx over 9 minus x squared raised to the 1 half. I will try to bring this one up. So dv is actually 9 minus x squared raised to minus 1 half times x dx. Okay. I bring out this one. So the exponent will now become negative. It seems this is under the power formula. Right? U will be 9 minus x squared. Du will be equal to, taking the differential, 0 for 9 minus 2x dx, or du will be minus 2x dx. This is not exact. Why? We are missing the value negative 2 over here, right? But there's no problem. We could now bring out the answer, but we must offset this one by placing negative 1 half outside. Okay? So this should be equal to, if we try to compute for value of b now, we place negative 1 half outside, right? Times the integral of 9 minus x squared minus raised to the negative 1 half times the complete differential. This is now under the power formula. B now is equal to negative 1 half. 9 minus x squared minus 1 half plus 1 is plus 1 half. So this is plus 1 half over 1 half. Okay? Simplifying, b now equal to negative 1 half. This 1 half here is under the denominator. We bring it up, we take the reciprocal. So this should be 2 over 1. Okay? 9 minus x squared raised to the 1 half is just the square root of 9 minus x squared. And luckily, these two here cancel with this. So what comes out? What comes out? The value of b is actually negative the square root of 9 minus x squared. There's a negative sign before it. Right? So going back to the initial problem, the integral of x cubed dx over the square root of 9 minus x squared, it's just a matter of substitution. This is UB minus the integral of B du. X square, U is X square, right? B is actually negative open quantity, the square root of 9 minus X square, minus the integral. Negative the square root of 9 minus X square, times du. What is du? It is 2x dx. Okay? This is the first part of the answer. The second part, it seems this is under the power formula, where the value of u is 9 minus x squared, du is minus 2x dx. We are only missing negative 2 over here. Okay? So to take the integral of this, we place a negative 1/2 outside, and this now falls under the power formula. Rewriting the first answer, plus 2 times minus 1/2. Why negative 1/2? It's the reciprocal of minus 2. Times, open bracket, power formula. 9 minus x squared, 1/2 plus 1 is 3/2, over 3/2 plus c. Final answer, negative x squared, the square root of 9 minus x squared. Okay. 2 times 1/2 is 1, right? This is 3/2. We bring it up. We take the reciprocal. So this will be 2/3. It's negative. Negative 2/3. 9 minus x squared raised to the 3/2 plus c. That's the final answer. Okay. Ladies and gentlemen, these examples are more complicated than the one that was given yesterday. We got example number 1, 2, and 3. Ladies and gentlemen, if you've got any problem, just bring out your problem. If you like my discussion for this morning, please click like. If you want to share it, please click share. And for those who are taking up integral calculus, okay, this is it. We are running smooth. We are now on the topic integration by parts. I have given you already 6 examples for the so-called integration by parts. Maybe again the next topic or next discussion, I will give you some more complicated before we go with the integration of natural logarithm. Maybe I'll give you 3 more. Then we will proceed with the integration of natural logarithm. If you want to subscribe, please click subscribe. Good afternoon now, Los Angeles. Thank you.